Fantastic. So yeah, thanks everyone for coming along for a second of our sessions in this little mini series of webinars, and really chuffed that Sam is able to join us as well. And I can see that Fidelity is also here, which is great because I know that Fidelity will have lots to contribute to the conversation as we go through as well. So nice to see you, Fidelity, and nice to see you, Sam. Yeah, so what we're going to do this evening is have a little look at a couple of the photos that were sent through from those very excellent students who did their homework, and have a bit of a chat about that. There's no right or wrong about what's in the photos, it's just observations, and so there's no judgment about what that means about your farming or your soils. It's just what are we seeing when we look at those soils and what's that telling us. And then we're going to have a look at water cycling and nutrient cycling on farm, and what that looks like in the soil and the role that the soil has in those cycles, sorry. And then, yeah, we're going to talk, Sam and I are going to have a chat about some of the ways that is playing out practically on the farm and the decisions that we make. And we're also going to touch on bale grazing as well in this session, very briefly, though I would imagine that's probably where the conversation is going to become quite interesting as more and more people are interested in bale grazing as a practice. So I'm just going to share, disabled screen sharing, even though I am also a host. That's a bit odd. Sorry, Sarah, I thought I was signed in as Pasture for live, so that's a bit... Oh, there we go, got it. Awesome, thank you. Sorry, I was a bit thrown there. So, can you see my screen? It should say homework, question mark. Excellent. Okay, so thank you, Chris and Christina. I was very excited when I looked at this photo because I could see a beetle down in the bottom of that hole, which I thought was great. So what I would be really interested in is kind of hearing some of your observations. So I'm just going to quickly rattle through a couple of the photos that you were sent. I haven't got all of them on here, but I thought this came from the same farm, this one and this one. Thought that was really interesting. And then I think these are Christina's two photos, which have blown up a little bit, so they're quite big there. But I'm interested to know what observations you've made. So Chris, I don't know if you want to say anything briefly about what you found on your farm, and maybe what these two, I think this one is by the hedge and this one's in a hay meadow. Do you want to just tell us what you've sort of seen there and your thoughts?
Yeah, I mean, this wasn't my farm, by the way. This is over in Oxfordshire, but because that's where I could do my homework. But no, it's very porous soil. We're on the alluvial plains of the Thames, I think. So it was all very crumbly. There wasn't any real definition, as I could see in most of these photographs, of any topsoil and subsoil. It was all very porous. And the two areas I took, which weren't that far apart, the first one, which was near the fence, which originally had been a horse field, but prior to that, going back into the 80s, had been dairy, but was now part of the garden. So it had obviously changed. And the second one was, again, part of the garden, but where my sister had dug it all up and turned it over to wildflowers, wildflower meadow, I suppose you'd call it. And I was just interested to see whether or not there had been a real change in the how the grass and the wildflowers had been affecting their root structure, if you like. In the wildflower meadow, however, it was evident that there was some broken bricks and other debris probably left over from when the house was refurbished. This was probably a dumping ground at that time. So it's maybe slightly poorer soil, but really you wouldn't have noticed it. That was it, really.
Thanks, Chris. Yeah, I mean, it's always difficult from a photo to kind of make initial assumptions. I'm going to talk very briefly about what I'm seeing on these two pictures, and I might be right, or might be wrong, might be right, but just in terms of what I can see. So I'm looking at this soil, it feels like it's quite dark, it's very crumbly, and it feels like there's actually, if you kind of put your hand in there, you could probably scoop up that soil and it would be very porous, and it would be lots of kind of crummy, aggregated, kind of small, like chocolate cake crumb within that soil. And yes, you can see on the left-hand side that even though you've kind of dug into there, you can still see that kind of crumbly aggregation. And then looking at this one, I would say that this is much blockier. So you can kind of see that at the bottom you've got quite a big kind of chunky block, and then you've got another block sitting underneath that. And actually the way that the soil is aggregated is in these bigger, chunkier blocks, which are often kind of defined or indicative of, mechanical intervention, which is exactly kind of
Nikki,
what you, yes?
Sorry, we're getting a very strange reverberation. Christine's getting it, and I'm getting it. I thought it might be my internet, but Christine's getting it too. I don't know.
I wonder if it's, I just need to Chris, is that better?
Could you speak a bit more? It didn't sound
is that any better? Is that different?
Yes, that's a bit better, yeah.
Okay, so Chris, if you can stay on mute for a second, and Sarah, if you could mute, then that way, if we've got everyone else on mute, maybe if we just have the, if you could just, I'm just going to mute you again, sorry Chris, you were just unmuted there. So so what I was saying is, hopefully you can hear me okay now, but what I'm looking at in this soil is kind of quite angular blocks, and that is indicative of mechanical intervention, which kind of aligns with what you were saying, Chris, about kind of things being dumped and kind of work happening here. So whilst if you pulled it apart, I think it probably would be quite crumbly. There are these kind of more angular blocks that are, some a level of kind of compaction and mechanical intervention. And then if we have a quick look at Christina's soil, I don't want to linger too long on this because we do have quite a bit to get through. But Christina, do you want to just maybe talk about what you saw here, other than that massively fat worm that's in the middle of that sample?
Yeah, so this is permanent pasture. We've had it's actually had a really busy summer. We've had cattle on there, we've had sheep, and now we've got the shepherd's training sheep, which is about 5 of them. So this was Friday, so we just had all the rainfall and everything like that. I was surprised to find, I think I counted about 5 worms in there, so I was actually surprised to find quite a lot of worms. The roots weren't that deep though, because I was doing also the root depth. Yeah, that was about 4 centimeters deep. Yeah, the soil was, it seemed quite a good dark soil.
Yeah. Thanks, Christina. Yeah. I would say actually, I don't know how much you pulled it apart, but quite often in order to do an earthworm count, you really need to pull the soil apart, particularly the top layer, which is where the leaf litter worms live. And then you'd probably actually see a much greater number of worms if you were really kind of basically have to completely pull the sample apart in order to do a full worm count.
I did pull it apart a little bit more after the photo. So this was right at the beginning when I took the photographs, and then I did whatever I needed to do.
Brilliant. Yeah, I was just to say that there might have been even more worms than you originally saw. But again, I think similarly, this is a really nice kind of example of that blockier structure. And you can see in both the photos, but particularly on the right-hand one where Christina zoomed in, where her finger is above the worm, there's kind of very clear, obvious channels and gaps between quite blocky structures. So it does look like, yes, although there are places where the water can run and where air can get into the soil, and we look like we're moving towards, it's definitely not fully compacted in any way, but there are blocks of aggregated compaction that even more kind of rest and more opportunity for those roots to get through will kind of break some of those up, because if you pull that apart, there's very obvious kind of seams running through it, and actually the earth between the seams is kind of quite tightly held together. So again, nice example of where that water and that air can flow through. However, it could be even more, it could be even less kind of blocky, and it could be more crumbly, which would help even further in terms of that water infiltration and air. So yeah, thank you both. I'm not going to linger too much on this because we do need to kind of crack on, but thank you both for contributing those. I think it's really helpful for everyone to see different photos of different soil types, and I really recommend going and having a look on your farm or in your garden or wherever, and just digging a hole and seeing what's there. And it's not a judgment of whether you've got good soils or bad soils. It's just about knowing your soils and being able to track change. So we're going to have a conversation this evening about water, carbon and nutrients on the farm, and the cycles that are supporting our healthy soil, such as having water infiltration, enabling carbon cycling, and also the wider nutrient cycling, and the role that the soil but also plants have to play in that. So just a wee reminder from the last time that we met, this idea of healthy soils with all of that connected porosity compared to compacted soils where no moisture, no air can get through, which then means that we end up without the opportunity to allow our soils to operate and cycle. And if we dive into the soil micropore, this is absolutely where we can kind of see how important these gaps and spaces and this porosity within the soil is, because these are the places not only that air and water can cycle, but if you see around the outside of this image, these kind of flaky parts of the kind of edges, this is where the carbon storage and the carbon can actually connect into the soil and be held and stored in here. So this is where the building blocks of a healthy soil really comes from that porosity, from having soil that isn't compacted, that has got space for air, water and carbon to cycle. Again, a reminder about what we were talking about last week, all of this interacting life, the microbes and the fungi, the invertebrates, the work of the soil microorganisms around the rhizosphere, that aggregation and that permeability all contribute to the healthy soils and allow these cycles. I can't express enough how important the idea of cycling is in these systems. It is absolutely key. And the soil is not a dead end place where stuff just goes. It is constant flux. It is constant change. And it's something I talk about a lot, this idea that we just get to a dead end with carbon and we just hold it somewhere is just, to some extent nonsensical. We're always cycling. There's always a process that's alive, a living organism, if you like, that wider soil system. So the regulation of carbon and nitrogen cycling is really key. And we know that we will get from the soil carbon dioxide and nitrous oxide emissions because of decomposition. And that is a very normal thing. We breathe in, we breathe out. And so gas is always in cycle for us as individuals, as humans, as it is for plants, as it is for other animals. So that cycling is totally normal. There is also sequestration and storage that happens, because we know that, carbon is the building block of life, and huge amounts of carbon are stored in the soil. And it is that kind of chemical backbone of life. Now, huge amounts, as I said, of soil are stored in of carbon are stored in the soil. Most of it is actually in kind of rocks and in sediments. The rest of it is in the oceans and atmosphere and in living organisms. And if we think about the soil and the ocean and people and animals, if we think of them all as reservoirs through which carbon cycles. So they're not places that are kind of fixed or static, but they are reservoirs where we maybe hold carbon, but it will inevitably be emitted at some point or used in some other way by an organism in order to have energy. So it's about exchange. There is an element of storage, but it's more about exchange and processing and cycling. So plants move carbon from the atmosphere into the biosphere through photosynthesis. So we can see in the top left-hand corner, we've got the sun, energy coming into those plants. So carbon is being moved from the atmosphere into the plant, into then the soil. And they're combining that carbon dioxide with hydrogen, with oxygen and water to make those sugar molecules, which are then, remember, our root exudates, going down into the soil profile and being traded for other nutrients that the plant requires. And then the animals that are, remember, I think I said 30% of the carbon and 30%, sorry, of the sugars that are made by a plant go down into the roots. So the rest of it is sitting in the leafy bit up top. And when animals eat that leafy bit up top, they are digesting the sugar molecules to get energy for their bodies. And then that process of respiration, excretion, decomposition, all releases that carbon back into the atmosphere or the soil, if we go back to our dung pat and the dung beetles, pulling that down into the ground, continuing the cycle. So there's this constant idea that it is moving, it is cycling. Then we think about our nitrogen fixation. So on the right-hand side, we've got some lovely red clover. We've got those nodules that are on the roots, these tiny little nodules that are created by a bacteria that works in symbiosis with leguminous plants, so vetches, peas, clovers, gorse, broom, all sorts of different legume plants, and that actually helps to pull down nitrogen from the atmosphere and fix it into the soil and make it a plant available, because plants aren't able to do that themselves. So they have to have that symbiotic relationship with the bacteria to create those nodules that is actually then making the nitrogen available. And they don't just keep it for themselves, they share that across the soil profile with other organisms, with other plants, working in collaboration, in cooperation, rather than in competition, which is what we're always encouraged to think plants do. Actually, they're far more complex than that. I can just see there is a question, so I'm just wondering if that, oh no, it's just Deborah saying if anyone has a question they can ask. So carrying on, plant diversity really does drive the agroecosystem function. So if we've got this idea of cycling, of change, of dynamism through our systems, the thing that is really going to enable that to be more effective, to be more efficient, and to create a resilience in our system is the increase in diversity of our plants. So ecosystems, or an agroecosystem, so a farm ecosystem, they all have functions which include the production of biomass, so plants, soil carbon storage, water storage and filtration, so actually filtering water so it becomes cleaner, and enabling immunity against fungal infections, insect attacks, etc. So the function of that ecosystem is all about kind of creating life, biomass, and the cycling of water, these kind of ecosystem services that we would think about. And all of the plant species that exist within the agroecosystem have different microbial communities that are associated with them. So that means that the plant diversity, so what we see above ground, is going to have a knock-on effect to the diversity below ground. So plant diversity may well determine soil microbial diversity and function. So the more diversity above ground, the more diverse the microbial community, and that microbial diversity can promote agroecosystem functions such as plant growth, nutrient cycling, decomposition, mitigation of greenhouse gas emissions. So the more stuff that we've got going on in the soil, all those microbes, we've got more of them, they're more diverse, they're all doing different jobs, they're more able to support that functioning, such as plant growth or cycling nutrients differently and creating more trade between the different plants or the other soil communities. So when we talk about having a more diverse plants above the soil, above ground, it's not just because it looks pretty, it does look nice, but it actually enables us to have a more healthy functioning soil system underneath the ground. It also means, if we think in terms of our resilience as farmers, and you guys down south will have had a much harder time of it last summer, not the summer we just had the one before, in terms of that long hot summer, and then this year with all this wet weather. If we just grow, for example, perennial ryegrass, and we have a very hot summer, then it probably is going to burn off. Or if we have a very wet weather, then quite often perennial ryegrass isn't able to stand up to that with consistent, constant ongoing rain. But if we have more diverse plants, they're able to cope with extremes of weather. And that's something that was just going to get worse for us, because we're not tackling climate change. We are heading towards tipping points. It's going to become more difficult for us to manage. So if we have that diversity, and we've got that microbial diversity, that can really help to change the soil properties. So that the more microbial action, the more biological action we have, the more that we see that soil aggregation becoming more chocolate crumb-like than the kind of clumpy, chunky, big, blocky aggregate. So if we get a blocky aggregate, generally demonstrates that there's been a lack of biological functioning. The more we move towards that chocolate cake crumb, that means that there has been more biological work, there's been more biological functioning, there's been more exudates, there's been more sugar and carbon exchange. There is then enabling more water permeability. So it's a very quick indicator. If you dig a hole, hold up the soil, and if it's crumbly and falls apart, generally it's biologically active. If it's blocky and chunky, generally it's had chemical or mechanical intervention. And that's fine, because it just tells us where it is in terms of the scale of soil health or function. But remembering that increasing that diversity above ground is a key way to help shift the balance of what's going on below ground. So soil organic carbon is a key part of that. We talked about it being able to be stored within the soil, and the soil organic carbon stability, the fact of whether it stays in the soil, is affected by a number of things: the molecular structure of that organic carbon, the physical properties of the soil, the chemical stability, so whether it's associated with mineral, clay, or silt soils, the microbial properties, so that activity and the diversity of those microbes, and also things like temperature and moisture. So the root biomass enables root respiration and soil respiration, both of which are emitting carbon dioxide. But that microbial biomass which is breaking down those roots, and the roots will inevitably die because, you know, with life comes death. So we end up with microbial necromass, so that's dead stuff, all of which is then fixing that carbon into the soil. That's sequestration and then storage. So plant residues, dead bits of root, and dead microbes is what basically makes up the soil carbon stock that we have in the soil. So it's not just about like this little kind of molecule that's kind of dinging about in the surface that then somehow gets into a plant that somehow then kind of is popped into the soil in a little chamber where it's kept safe. The soil carbon sequestration is a process of life and death, of exchange, and of residues and respiration and you know, that microbial activity, which then allows that carbon to be stored deep in the soil. And we know also that the depth at which you're measuring soil carbon will give you a very different picture. So deep storage of carbon is something that only happens after many years of that carbon cycling process happening, but also enabling water and air to get deeper into the soil. There's this kind of quick active cycle of carbon that happens in the sort of top 15 centimeters, which is where kind of all the busy work is happening. It's actually much deeper that we need to look for that long-term soil carbon storage, which is why for any of you that are thinking about maybe in the future, or if you're not already, selling your soil carbon as credits in order to companies to offset their emissions, it has to be down to a meter. You have to be measuring and baselining at a meter deep. Now, I think there's all sorts of ethical issues around whether we do that or not, but that's why if you are going to do that, it has to be deep in the soil profile. So we've talked about carbon and actually thinking about how that relates to water. So we know that the greater the soil carbon content of the soil, the more it is able to hold water. So if you think of, there's a great example that's given about a plate of flour. So imagine a plate of flour which is it's been ground and it's a plate of flour and it's got no kind of structure to it. It's just almost like compacted soil that's just kind of sitting there. And if you tip water on it, you basically either get it pooling in the top and then eventually it kind of seeps in and turns into this horrible glue. Whereas if you turn that flour through a process of biological action, that is adding in yeast, and you then go through the process of making it into bread, and you pour the water on the bread, and the bread has obviously got the holes in it and it's got structure and it's able to hold itself up. If you pour water on that, then it's going to seep in, it's going to act more as a sponge. So it's not exactly the same as compacted soil versus carbon-rich soil, but it's a nice way to think about it. You know, a plate of flour versus a loaf of bread, bread is going to hold a lot more water than a plate of flour. And so when it rains, that precipitation, the infiltration and then the deep percolation is what we want to have more of so that we have less surface runoff. The last thing we want is for that water to be disappearing off farm. We want it to be captured by the biomass above soil to enable that infiltration, because we've got that connected porosity underground with deep roots that are enabling deep percolation. And it's that deep percolation that and then enables us to contribute to the broader water, to reduce the risks of water scarcity and to make sure that our reservoirs stay full, and that we're able to actually within our catchments have a more healthy water cycle that isn't so kind of boom and bust. We want to hold as much of that water as we possibly can in our soils, as far down and deep into our soils as we possibly can. And soil compaction is the thing that will stop that from happening. I may have mentioned this last week. I've done this webinar too many times to remember whether I've said this last week or the last time I delivered it, but you know, I go onto farms and I'm told, oh, this is a muddy, wet corner, and oh, it's so wet here, it's just really difficult to manage this field. It just always sits in water, it's just so wet. I dig a hole in a puddle and underneath it's dry, bone dry. If you dig down 20 centimeters into a puddle, the number of times when that soil is bone dry, and that is absolutely 100% telling us that that is a compaction issue, that the water just cannot get into the soil. So we have to remember that, yes, when we have ongoing, consistent barrages of wet weather, there are going to be times when there is only so much that the soils can take. However, that is a hell of a lot more than most of us give credit for, give the soil credit for. We really can hold a huge amount of water in our soils, but we have to create the conditions through which it can actually get down into the soil profile. So we want our water to be stored in that profile and not to run off into watercourses. We want to slow the flow, we want to hold water in the land, and we want to treat our farms as sponges. What we don't want to do is have water just sitting on the top, because it, as you know, is not good for the soil. We then create anaerobic conditions. So if we get a really wet soils and there's no opportunity for the air to get in, we then shift to an anaerobic condition, which basically suffocates out life. And it means that we're not able to have plants and microbial activity that are actually able to function. And some of you may have rushes in your fields, and if you do, you might notice that they tend to grow in very wet areas. And what is happening there is that they are specially adapted to cope with anaerobic soil conditions. And quite often, if you look at a soft rush, and you dug up the roots and you looked at them under a microscope, you would see that they are hollow. And the job of a rush is actually to help kickstart that cycle to get air into places where air cannot get because they are waterlogged. So quite often, I mean, and this comes on to maybe later conversations about rush management, where actually, why do we want to manage the thing that's fixing the problem for us? And this is a theme that you will find I repeat in most webinars, that sometimes weeds or problem plants actually are not problematic, they're symptomatic. I just very quickly want to touch on bale grazing. Let me just go, yeah, I'm going to come back to that. Before I go on to bale grazing, sorry, I put my slide in the wrong order. I just chucked that bale grazing one in. Excuse me. Let me just grab a drink. I wanted to show this very quick picture. So Niels Caulfield on the Soil Mentor website did a really good blog about infiltration rates. And so infiltration is a way that we can measure how good our soils are at cycling water. So what we do is we get a tube, so a bit of gutter or something like that, that's 15 centimeters wide and 15 centimeters deep. We hammer it into the soil so that it's about halfway in. And then we tip an inch of water, so what would be an inch of water in that tube, into the tube. And that's our buffer. And then we pour a second inch in, and that's the one that we're actually going to measure. Now, this demonstrates the soil, the plant kind of sample or the root sample on the left. It took 7 seconds for that second inch of water to get into the soil, to disappear. That was in the field margin. That plant there is cocksfoot, has really deep roots. You can see that actually the rooting depth is probably twice that of the sample on the right. So there's a lot more opportunity and space and places for that soil, for the water to percolate through the soil and to infiltrate. On the right-hand side, it took over 20 minutes. So 7 seconds on the left, over 20 minutes on the right. Same field, one in the field margin, one in the reseed. And it absolutely shows the importance of, if we are facing a deluge and a downpour of rain, if it can get into that soil quickly, 7 seconds, it's going to be significantly different to the risk of runoff, to the risk of flooding, than on the right-hand side where it took over 20 minutes. Think how much rain can fall in 20 minutes versus 7 seconds. So we really do have one chance and one chance only, as Neil says, to get water into our soils, and that is when it rains as infiltration. And once it's in there, we then are able to store it so that it's ready for when we need it, when it gets dry. If we can't store water in our soils, it won't be there when we desperately need it as we hit a dry period. So I'm just going to jump back one, because I think Sam and I are going to probably talk about bale grazing. And I just want to very briefly mention that the role it plays in boosting nutrient cycling. So we know from some research that happened in North America, and it's research that I'm currently replicating along with 6 other farms in the UK. We're actually measuring the change that happens below where the bales have been rolled out. And we've seen in the US from their data that we see increased organic matter, which, as I've said, has implications for water holding capacity. We also see increased forage production and improved forage quality underneath where the bales have been rolled out. So these are approaches that are helping us to almost kind of boost that cycling capacity of our soils, of our fields. So I'm going to stop sharing now. And I'm going to open up for a bit of a conversation and a chat. So I've thrown a lot of information at you again this evening. But Sam, I want to come to you. And before we open up for kind of broader questions, can you just talk, Sam, about, I mean, it's been really wet. Can you talk a little bit about how you've been managing kind of the wet weather recently with your grazing, and whether that's changed over the last few years and the changes that you've seen on farm?
You know, it has been very wet. We've also been TB testing, whole herd TB testing last week, which we passed. So this might be our
Good news.
first interval, which would be nice. So when we TB test, we have to graze the cows in the wettest fields that we've got, which are right by the building. So this year we gave them a full year's worth of rest in anticipation of it being really wet when we TB tested. We also spread compost on top of the long grass in, I think that was the end of June, which pretty much seemed to disappear. But, you know, having that really long rest has definitely altered that field. And you know, it stood up quite well this year.
What can I ask? What led to you putting the compost on? Like, where did that come from? And is that the first time you've done it, or is that something you've done lots of before?
So it's homemade compost, so from farmyard manure and wood chip mixed in. So we only started doing that a few years ago after a lot of composting talk at a groundswell. But yeah, the reason I put it on that field was because that, as well as being the wettest field, well, I guess it's the reason it's the wettest field is there's a lot of yellow clay. You know, as soon as you dig a hole in there, it's sort of our most shallow topsoil with a lot of yellow-orange clay underneath. So I'm really trying to improve it, really, and improve that water infiltration there. But you know, that worked really well. We did house some other cows, but we housed them for TB, and that was our wettest week, and we've now turned them back out again. So currently everything's back out at the moment, and the cows and calves just moved into their winter bale grazing today.
I really love what you were saying about, like, you gave it a good year's rest in anticipation, and I think that's something that really, the more you practice these kind of adaptive multi-paddock grazing strategies, or mob grazing, or, you know, holistic plan grazing, whatever kind of grazing strategy we're taking, generally what they all require is a lot of brain power and planning. And actually you kind of learn that the game isn't about how much grass can you eat, it's about how can you make sure you've got grass where you need it when you need it. And that rest becomes really important, right? Yes,
and if we'd have had a drought, we might have come in there and grazed it earlier. It was, you know, we got extra rest this year because we grew grass all summer long. So yeah, last year different.
Are you measuring infiltration rates or soil carbon or anything like that on your farm, Sam?
We did some total soil carbon tests today. A guy came here, and to Fidelity's Dave, I think he's on the research group, isn't he?
Gollins, brilliant.
Yeah. He bought his new toy out.
Very important scientific equipment, Sam.
So we've done some loss on ignition tests previously for soil carbon. Just as a bit of a baseline. I think that was 5 years ago. But yeah, we've not done a lot of infiltration tests, and it varies so much, I find, everywhere you do it. But it's not, I like the digging the hole method. I like to dig holes and look at the soil. And the more you do it, then the more you notice and the more you see, and everybody's soil it's very individual.
Yeah, absolutely. I was really lucky last week. I got to dig lots of holes in lots of fields, and the week before on all different farms in different parts of the UK, actually, and it was just amazing just to see how different they are, and your kind of what you notice, and your power of observation really does kind of develop the more you do it. And you can really kind of see those gaps where the water and the air can cycle, and you can kind of see those riser sheaths. I think Chris as well, in some of the photos he sent through, was showing the rhizosheath, so that kind of sticky, kind of hairy coating, or kind of brown muddy coating around the roots, which is showing that kind of biological action that we talked about last week really happening. And the more you see it, the more you kind of recognize it, and the more you start to value it. Fidelity, I'm going to make the most of having you here as well. So just wanted to ask, in terms of wet weather, how have your fields been holding up, and have you been doing anything differently over the last couple of years, particularly where we've had really dry weather, really wet weather, and yeah, what have you noticed?
Well, so I noticed something absolutely brilliant the other day. We had our local agriculture college invite themselves around for a session, and we wanted to dig some holes. So we went into 3 fields, and I'm really bad. I think Soil Mentor is a brilliant app. I'm really bad at using it. It gets put to the bottom of the list every single year, and I hadn't done it for 3 years in a field that we've really systematically grazed, mainly mob grazing, but also the sheep had run across, not taken any hay from it. And I could not believe the change in just 3 years from when we last did it. And we compared that to the field next door, where we'd taken a couple of hay crops, and it was nowhere near as good as the one that had been mob grazed. And then the worst field was a field that had had lamanitic ponies grazing it for 20 years down to a golf course. And it's terrible. It's absolutely terrible. Even though we've bale grazed it now for 3 years, it's still really bad. So it was really satisfying just digging the holes and showing the students, you just with your own eyes, what you could see. So that was great. At this very moment in time, we are incredibly wet at the moment. We're on very heavy clay soils, but actually I've got a plan for we've got a meadow restoration project, and this is exactly the time when I'd got in some really nice species rich hay from somewhere else, and I especially wanted to put it into this particular field, bale grazing it as we went. And I've been determined not to let the weather stop me doing this. And they've actually held up. The fields haven't been grazed for, well, probably since early summer. So there's a really nice wodge of grass there. I have moved them twice a day on a couple of really bad days, and on one day misjudged it and they poached it a bit. But actually, despite the weather, really happy with the way the bales have been grazed down. But also we try and graze once a year things down, so it's really quite short. So unlike the usual mob grazing when you leave a lot, this field I've decided to do it now. So there's lots of open spaces for the seeds to germinate that we hope are going in. And I mean, the water is sitting in puddles all over the place because the cattle have puddled it a bit, and they haven't gone through the top, but I feel happy about it. And yeah, we'll wait and see. I'm really excited now about next summer to see if these seeds we brought in on our bales will actually have germinated.
And that's a really interesting point, Fidelity. It sounds great, and yeah, I think there's a few of us now that are kind of real converts to bale grazing, and we're seeing these real the role that it can have in shifting diversity of our swards. But Nicole Masters talks about when she talks about kind of subsoiling, or that idea of like rip and drip, where if you're subsoiling or you're ploughing and you're kind of at that point where you have to, then adding something in at the same time as a feed source for the microbiology is really important. And actually thinking about it, bale grazing does exactly that. So there's inevitably going to be some kind of residues left over from the bales. I mean, we do want our animals to clean up as much as possible, but the seeds that, if we're creating a bit of a pugging, we're poaching a bit of pugging, but the seeds are going in and a bit of that additional organic matter, and there's also going to be the dung and urine deposition from the animals. We are kind of doing that rip and drip, if you like. We're causing disturbance, but we're feeding the soil at the same time. So it's not the same as just poaching it and then wondering what's going on. Actually, we're adding all of those nutrients back in, so we're boosting that cycle, and we're giving the ability of the soil to have something to kind of help restore it as it then rests and recovers after that kind of bit of poaching that we'll be getting at this time of year, possibly.
I think that's true. I think though it's so easy to just poach it a little bit too much, and it takes ages to come back. And also the other thing that's so easy is you leave a little bit too thick a lump of hay. And so in fields that we've done that in, you can see where you rolled out the bale and they just didn't graze it enough, and it's not come back for a year. I'm quite sure it will come back, but it's, you just have to do your best all the time and accept that it's never going to be perfect, and there's always going to be little bits that don't work quite as how you'd like them, but they do in the end sort of rectify themselves well enough anyway.
Yeah, nature is pretty good at healing. She fills the
Yeah.
gaps.
Yeah.
I wanted to see if there's any
Yeah.
questions. Sorry, Deborah.
Thank you. So,
Yeah.
yeah, just going to suggest that I know that Christine and Zoe are on the call, and they started Springham about 3 years ago. They're surrounded by water, so I just wondered if they might like to contribute a little bit. I have asked them private in the chat, and Christine has agreed. That's all right. Because I just thought
I can speak. Well, the thing I would say is that for Springham, we're only on our second winter. So we did 2 summers without a winter to start with, as it were, which was quite fortunate. Of course, it's the heavy clay, and the name of the farm kind of gives away. It's nature, Springham. It's the hamlet from which there's about 5 streams start on the hill. So obviously what we notice is that with the longer grass, there's far less runoff. We've got 5 streams, and in the last week, those streams have been running into the Cookmere, which has flooded, I think, 3 times already in the last 10 days. So we noticed that the water quality coming off the long grass is much better in the streams than it is down in the main river, where it collects a lot from the maize fields upstream as well. So that's quite good. I would say that we're slightly different to Fidelity in the sense that last winter we opened up plenty of spaces in the soil, and that allowed things to germinate that perhaps we wouldn't have wanted too much of. And now we've not got as much space in the soil. We're trying to leave a bit less space for things this year, but to do plenty of trampling. And so far, it's okay. I mean, Steve and Zoe have been doing a good job working out and learning for themselves in this is their first winter moving the cows across the ground. And really, we're still learning about the stuff that Sam knows already, where the wettest fields are and how much those need enriching and resting at different times. So I'm kind of 1 year ahead of everybody else who's working with it. Zoe, would you like to add anything to that? Didn't mean to put you on the spot.
I don't think so. Stephen said he's happy. So, like I say, we're still learning, but it's going okay, I think.
Brilliant. It sounds great. And it is just about kind of taking the time to work out what works best for you. And I mentioned this bale grazing group that I coordinate. And what I love about it is that we have farms all over the UK, from clay to sand to we're on podzols where we are. So there's a real range of different soil types. And I think, and beyond that, there's a kind of wider community of people that are bale grazing, and who every year there seems to be more people giving it a go. And basically it's the same. In order to kind of bale graze effectively, you also have to have decent kind of residues, and you have to have decent stockpile to bale graze on. And I think more and more people are realizing that actually managing for winter, if you can manage for winter and you can manage for those wet periods by having healthier soils during the rest of the year, then actually you're kind of building that more resilient system, particularly in terms of keeping costs down. I don't know how many of you are on Twitter, or X as it's now known, but James Rebanks did a really great thread about outwintering his cattle. And so he talks about being 1,100 feet up in one of the wettest places in England with a short growing season, and that it still works, and talks about making sure that you have that you don't have that you make sure that you have a stockpile, and this idea of having more plants with greater roots, with a greater covering above ground, to actually moderate and mediate that rainfall. So as the rain hits, it's not just hitting soil and creating a capping system. Actually what's happening is it's hitting plants, and as it hits plants, the water droplets are dispersed. And then it's much easier for those smaller water droplets, they've got less energy in them, actually to slowly infiltrate into the soil. If you think you've just got like bare earth and you've got raindrops just constantly hammering down on bare earth, eventually what happens is where they're hitting just becomes compacted. It's this very thin surface level capping that happens, and it means that it just gets harder and harder, and the more that the rain hits it, it ends up just running over the top, you know, like that flower that I was talking about. Whereas if you've got a load of different plants that are sitting like this on top, as the raindrops hit that, they kind of hit at different angles, and their energy is dispersed, and then the rain is able to drip through the gaps between the plants. So that biomass on top of the soil is just as important as those roots underneath, and actually mediating the impact that rain has as it's hitting your ground is as important as what's going on underneath the ground. Because if we've got that bare soil, or if we've got low basal ground cover, so that means that if we look down on the soil from above, we see lots of bare soil. If you stand in your field and look down and see soil, you're increasing the risk of capping, you're increasing the risk of compaction. If you stand on your field and look down and just see plant material without any soil, then you're significantly improving the chances of healthier soils and water infiltration to happen. So that's quite a good thing to go out and have a look at and see what's going on in your paddocks. Deborah, did you want to come in? You've unmuted. You look like you're ready to come in with a question or a comment.
No, just that I was waiting for you to finish because it's fascinating, but I just wondered also whether you could talk about the impact of the water cycle on cooling, because obviously there's the infiltration, but in the summer, because we suffer a lot with drought here, that plant cover also has a big impact.
Absolutely, yeah, and I think I've got it in one of in the last webinar, which is around managing extreme weather. A really great slide that shows the difference of temperature between bare soil and plant cover. And so it was actually really interesting. There's a mob grazing WhatsApp group, which is a brilliant source of information for anyone who is doing that kind of mob grazing approach. Like Sam and Fidelity are both in that group, and I remember during the drought in 2022, there was like photo after photo of people with these kind of, is it like a laser thermometer? I don't know the technical term, basically pointing their thermometers at things, whether that was the road or the verge or a hedge or their field or pre or post grazing. It became a little bit ridiculous, actually, of lots of people going out obsessively recording the temperature of places on their farm. And what we were seeing in that is that the places that had, I mean, unsurprisingly, the most grass, the most biomass were much cooler. And what we were also seeing, and this was a really interesting part for me, was that folk practicing that kind of tall grass grazing were actually able to capture dew, whereas people that had kind of grazed everything right down didn't have any way of capturing the dew in those really hot months. And so dew might not seem like a lot, but actually it can make a significant difference to whether the plant is stressed or not, whether it's got a bit of water. Now, there will be times during extreme weather where you don't have any option and you are just, you know, you kind of, stuff isn't growing behind you and you are just getting through your stockpile ahead of you. There is inevitability around that at some point people are going to become unstuck, and we all have to deal with those situations. And it's at that point we either destock, we need to sell animals, or we need to find somewhere else to put them, or we need to start feeding hay. But our job as farmers who need to be resilient is to reduce the risk of that as much as possible. So if we know that we're going to have more unreliable and volatile weather systems and climate change coming our way, then if we can think, right, I know that a good way to mediate that is to have lots of biomass, lots of plant material on top of the ground, then we can start to manage our grazing and manage our farms to create more of those conditions. And as I said, yeah, it may be that we get to a point where we've grazed it all out and then we're left with no feed, but hopefully in a maritime climate like we have, rain will come eventually, but sometimes it can just be a very long wait until we get there. Do you just want to kind of make space for some questions? Because I don't think anybody's asked a question yet, other than Deborah. Is there anything that anyone needs clarification on?
Yes, I've got a query about bale grazing and putting, as Sam was saying, putting it on wet fields. If your soils are saturated and therefore not breathing, if you're then putting a wet bale on it and that's getting trampled in, is that doing? I'm just wondering what time of year maybe you should be doing the bale grazing in the wettest area, wettest time of the year. Which case, are you getting the best benefit from that bale? This is forgetting the reseeding bit. This is just doing fibre into the soil, or does the soil need to be reasonably well draining but damp, if you like? to get the benefit out of the bale going into the soil. Otherwise, it's just going to become anaerobic, isn't it? And get rotten. It's going to go rotten.
Sam, do you want to come in with your thoughts on that? I've done a lot of chat, so then I can come in afterwards.
Yeah, no, I think the rest is the key there, Chris. You know, if you can afford to rest a bit for a whole year before you start doing it, you know, then that's going to allow your root mass to get a lot further down, and then it's hopefully it won't become anaerobic. You won't be able to do that until you start rotating and sort of budgeting your feed, and then once you can spot that you can leave areas to rest, then you know, then you can do it.
Yeah,
yeah,
no.
In the summertime, if you're dry, you can always, if you've got poor areas like that and you're dry and you need to feed some hay, it's a good place to put the cows or sheep to feed, you know, in a drought as well.
Yeah, no, I can see that. No, it was just that question of, or the way the message came across earlier was that if you got wet areas, then you put the bale on it. And you're saying that isn't actually what you did. You did it the right. You let time work as well, and that you're putting the bale onto an area that is predominantly wet, but so you got the greatest benefit from the bale going on to that part of the field.
Yeah,
that's
definitely
really where I'm coming from.
I would start bale grazing on your dry. If it's winter bale grazing, do it on a bit of the farm. Definitely
Yeah, I think Sam was talking about keeping some resting so that he could turn animals out for the TB testing on the wet ground, and then the bale grazing is maybe not in exactly the same area. So I think that kind of all came together there. But yeah, you're right. Like the long rest, and I think just just to reiterate that if you are going to bale graze, you need to do it on a stockpile. It can't, and a really good way to do it, for example, is if you cut your hay, and this is what we did last year. We cut hay where the bales came off the baler, they just sat there, didn't move, and then we bale grazed back on that. And because we cut the hay, let's say, I think when it was the beginning of August 2022, by the time we were then grazing it in December, from August through to December, it's had recovery. So we've then had, several months of rest after the hay cut. And because taking a hay cut, as Fidelity has suggested, you can see the quality of the soil, and the soil health underneath the hay cut isn't always great. So for us, it was important that we're feeding that hay back onto where we had cut it, so that we're still cycling those nutrients. Because I'm going to be honest, nowhere in nature does a hay cut happen. It's a very human interventionist approach. So if we want to be guided by natural cycles and processes on our farms, taking hay and putting it somewhere else probably isn't ideal, but I recognize that we also have to make sure that we have conserved forage available for our animals. So that's one of the trade-offs that we have to deal with when we're managing a farm and a living ecosystem. But feeding hay back where it's been cut gives you that long period of rest between the hay cut and the graze. If we treat a cut like a graze and we make sure we have long rest afterwards, or we might want to put bales out on pasture that has been rested, but it's really important you get that rest in. Christine's got a hand up, but Fidelity, I think maybe you want to come in and then we'll come to Christine.
I was just going to sort of add to the business about bale grazing on wet ground, because I mean, as you rightly say, the stockpile is absolutely crucial. And what can easily happen is that you start off and it's dry, but you need to keep on finishing to get through the field, and you get some really, really wet days. And I think one of the things I've sort of discovered this year is actually, although it seems an absolute ball ache, sometimes you just have to move them twice a day. I mean, some people do them more, but if it's so wet that they're going to go through the sort of top, so even through if you haven't got a massive stockpile, you don't want to break through the turf at the top. You want to keep that intact. Then to stop them making a mud bath, then I think you definitely just have to move them twice a day and try and set your system up so you can easily do that on the wet days you have. One of the things I learned when I last went to see Sam was the business about, you'd see a huge, great big hole in his ground left by a cattle hoof, and he made the point that so long as there's grass in the bottom of that hole, it will always recover. What you don't want to have is bare soil left at the end of it, and the way to avoid that is just to move them more quickly.
Great point, Fidelity. And I would say, just before Christine comes in, just to add to that, at the moment I've been grazing a very wet hillside, that because it has clear fell forestry happening above it, it's completely changed the hydrology of the field. And we've now just genuinely got streams and burns coming through where there weren't any before. And so we actually, that normally our winter grazing across that field, it's a 40-acre block. There's a real mix of like there's scrub, there's trees, there's open species rich grassland. And normally it takes us ages to get across it. We go really slow and steady through the dormant period. And it gives us a long time before we get back down onto our kind of in-by ground. Because it's so wet, we have been moving much more quickly across it. But that's okay, because we'll just come back in April. And we'll go back over it in April, because sometimes if you're moving quickly, as long as you're not kind of poaching and doing too much damage, and we're leaving quite long residuals, there's going to be something for us to come back on. So it's always about having those options, having that scope to tweak and shift the system. Conscious of time, so I'm going to go to Christine, who's very patiently had a hand up.
Thanks, Nikki. I was just going to really pick up on something Chris Martin said and link it back to the conversation about bale grazing, is that I feel it's become really important for me to learn when is the best time to try and get compost out there or bales out there. Is to, if you want the greatest effect, is to do it when the biology is active in the soil. But there will be times when the biology isn't so active. And certainly I noticed with the very substantial drought in 2022, and that, you know, so the soil biology got fried, and then the soil biology got drowned where we are. And that, I think, in some areas really knocked it back, and it's still in recovery from that period.
No, that's a really good point, Christine. And actually, yeah, that's where the long rest comes in. Because if you're bale grazing in the winter and you've got some of that residual hay left over, that long rest means that as the temperatures warm up and the soils become more active again, and that dormancy is, you know, we come out of that period of dormancy, then actually the microbiology is able to kind of start using that food source that is available that's been left from some of the small amount of hay residual that you'll likely have left over. Debbie, you've got a hand up.
Yeah, it's just going on what Fidelity just said. So I just want to make sure that I'm correct with what she's saying. So Fidelity, you said that you know, you would move them twice a day. Would that mean that you wouldn't bale graze at all, and you would just move them twice a day rather than give them extra?
No, I have been bale grazing, partly, well, for two reasons. One is because I want to the main reason is that the main aim on this particular field we're on the moment is getting new seed back into the grass. So I definitely want them to eat a bale of hay. There actually is enough grazing out there that I don't need to feed that bale of hay. And so I'm just thinking through the answer to your question, which is that if you didn't want to, if you had a nice wedge of grass, then there's no need to feed them that bale of hay. What you're gaining by having them in a small group and moving them on is a lot of very well regulated poo and wee on the field, because they're in a small patch, and moving them on. I suppose that, but there is also a view, actually, it's the view that's current, this WhatsApp group that Nikki was talking about, which is that if it's very wet, it's actually better to give them a bigger area so they're not stomping it too much. So I'm a really bad planner. I like to make a decision as I go out there and see what it's looking like, what it's been like the day before, and go for it like that. So, but I think that if you've got a nice wodge of hay, so I'll tell you one thing, Debbie, that I really learned a lesson last year, was that I found it so painful pulling out a bale on top of a lovely wodge of hay and thinking they were going to waste all the hay underneath it. And sometimes we'd have them in a section for 2 days, let them graze it off a little bit, and then put the bale out for the second day. But I reckon we got much worse poaching doing that, and it was a mistake. And so this year I've been putting the bales out on top of nice grass, and actually by the morning I'm really happy about this. They've trampled a lot, they've eaten a lot, they've eaten the hay, partly because it's wet. I think they probably like the dryness. They've probably laid on the hay as well, which is a little bit annoying. But so I think I'm not really giving you a very straight answer. I think you have to sort of make those judgments for yourself as you're going. But if you don't want to feed out hay, there's no reason, unless Nikki, I mean, Nikki'd say, well, why don't you do it because you're getting bulk back into your fields by the residue, and I'd say you're getting seeds in. But if you don't especially want to do that, then you can just move them quite quickly without feeding them hay. You don't have to do it at all.
I think the problem that I have is that with the 2 storms that we've had recently, everything is wet, and so moving the cattle quite, twice a day, but also giving them something to eat, on top, because they're every time they see me they moo. So I'm not sure whether they're hungry or not, really, to be fair. But they are on a good amount of grass. The only problem is whether there's enough in that grass to keep them going, which is the big question, really, I suppose.
I think that's a really good point, Debbie, because that idea of like very wet, washy grass just doesn't really fill their rumen. And so I think sometimes adding a bit of hay or straw or haylage into the mix does mean that they're just getting something that's actually filling them up. Because if you just kind of had washy lettuce to eat, you're not going to feel particularly. I mean, I definitely would need to at least put it between 2 slices of bread to feel like I've actually eaten like a meal. So I think there is something about, when it's really wet, giving them that, which is where the kind of stockpile deferred grass comes in. I'll share a picture next week of like what I liked. So my cattle are just moving on to one of my favorite places to graze anywhere. And it's just like this long 60-day strip grazing block, graze it once a year. It's curlew nesting habitat. And it's such a mix of some old stuff, some new stuff. It just, that as they get a mouthful, it's going to be such a mixed bite. And as it goes through into their digestive system, some of it's kind of protein rich, some of it's fiber rich, and it's really going to be a good mix and get them full. And I want those rumen, I don't want to see a dippy rumen. I want to see a nice fat belly when I come to move them. And so I think, actually just maybe topping them up with a bit of roughage, whether that's hay, haylage or straw, can really help. And I think Fidelity, that's probably what you've seen as well.
Yeah, I think the other thing that's really interesting is that when you first, so I roll out the bale of hay before I move them into the paddock, and it's interesting when you watch them and they go in. So they're going into fields that have actually got some really nice clover in them, some overblown grass and some hay, and they will mooch around and they'll take a little bit of everything. So it's not as though they save the hay for when the grass is gone, but actually they'll go from hay to grass to clover and back again. So they sort of seem to be enjoying the 3 different types of forage that they're being offered.
Next week we're going to talk more about kind of grazing strategies, and we will focus on that on wintering. But I guess I just want to come back to the main focus of this webinar, which is about cycling, and just to say that the kind of bottom line to all of this is that there is no waste in nature. And sometimes as farmers we get a bit hung up on this idea of waste or not utilizing something because we exist in a paradigm that's quite extractive, where the expectation is that we will take every last bite off a field or we will use every last bale. And that actually, sorry, Chris, I've just muted you because there was a little bit of feedback from the microphone. So this idea that we have to use everything in order to be good farmers or to be efficient, I think actually can be our downfall a little bit. And so learning that you can move animals on whilst there's plenty of grass left behind, because actually it is too wet and they just need to move on, or leaving a bit of hay on the ground, or as Fidelity was saying, rolling out a bale on top of quite a nice chunk of grass and being a bit worried about that, and that, it's a bit of a waste of the grass. But actually this idea of waste is something that has kind of been developed in response to quite an extractive paradigm of agriculture. In nature, as I said, there is no waste. Everything comes back to the earth, contributes to that cycling. And so I guess if you're ever standing in a field thinking, oh, I should have left them on there a bit longer, or that hay left there is a bit of a waste, it will break down eventually. And it might take 6 months. In some cases, it might take a year, but natural processes will mean that it is contributing to the health of that soil and it is improving things. We just have to be patient. Which is hilarious because I'm the most impatient person that I know. So for me to say that we need to be patient is a bit rich, but I think sometimes we kind of expect things to happen quickly. And if we're taking on grounds that is, or we're kind of going through a transition with our ground, it will take time. I've got fields on one of the estates that I manage for the grazing for, where the grass just doesn't seem to break down. It's sort of, when we took it on, the grass would say maybe fall over, and they would just sit there and it just wouldn't break down. And it's only since like more rest, more trampling, more integration of cattle that we're starting to see the biology kickstart. So it does take time for this stuff to happen. So please be patient with it. And always remember that, you know, there is no such thing as waste, and that it will all contribute to worm food in the end. So yeah, it's a difficult mindset to sometimes get out of, but it's really worthwhile once you do kind of get there, because you realize that nature actually does a lot of the heavy lifting for you. We've got 5 minutes left. Are there any other questions or comments? Anything, Sam, you want to add that we've not covered?
I've got a question for you though. Diversity is good, but how do we get that? What's the best way of getting that diversity? And is diversity out of a bag equal to naturally occurring diversity?
Well, that's a good question. I like the second bit more than the first bit. That idea of, yeah, so epigenetics, the ability, the genetic switches being turned on within any plant or animal in response to its environment would suggest that naturally occurring diversity is superior to out of the bag diversity, because the diverse plants that you have that have come from the seed bank, for example, will be genetically predisposed to function and perform in that setting. However, sometimes that's not possible. And so diversity out of a bag in terms of a mix that you're buying from somewhere definitely can still contribute to that diversity. I am yeah, I think, well, Plant Life come and talk to me a lot because I'm the Mrs. Anti-GS4, I think, is what I've been described as. I have concerns, particularly with the latest round of new SFI management options. I do have concerns that we are losing a lot of our native diversity to herbal lays. You know, they're kind of pretty sexy things, aren't they, herbal lays? People talk a lot about how great they are, but actually
Nikki,
there are challenges. Yes, Deborah.
So Debbie was just saying she's lost. So I wonder if you could interpret the acronyms you're using.
Yeah, sorry. So epigenetics, is that the bit, Debbie? Yeah, okay. So I'm conscious we've got 3 minutes left. So 3 minutes on epigenetics. But in all of us, we have genetic, like we've got genes, right? And they give us red hair, blonde hair, blue eyes, whatever. But there are things that are kind of genetically, we're predisposed. But we are all shaped by our environment. So people who live in countries that have a lot of sun are able to cope with heat better than, for example, me with my very pale skin. I really struggle if I go somewhere hot. You know, Scotland is definitely the place I should stay. And there's a great example that a good friend of a number of us in this group, Rob Havard, he would talk about the more you drink alcohol, the more alcohol you can drink, right? If over a period of time, the more you drink beer, and then you kind of go out and you drink 3 beers, and then the next time you drink 5 beers, and I'm not kind of advocating alcoholism here in any way, but just trying to, as an example, you know, we know that the more you drink, the more you're able to kind of cope with that. And your genetics actually start switching on to be able to not just your adaptation and the way that your body adapts to that actually is at a genetic level, not just on a kind of, oh, my stomach has got a bit more of a lining to it, for example. So, and that happens over generations. So, for example, so I get the hides off my cattle when they go to slaughter. And what we're seeing is that through the system that we're pushing our cattle through, their hides are getting thicker. Every year we get slightly thicker hides, not by a huge amount, but we know that the hides are getting thicker. And that is a genetic or evolutionary adaptation that is happening in front of our eyes, and is as a result of this thing, epigenetics, which just means a genetic shift in response to the environmental conditions that an animal or a plant experiences, and then is further enhanced through the next generation. So if we have got plants that are coming from the seed bank, they are genetically disposed to perform the best they possibly can. They're optimized for that particular bit of soil, that farm, that riverbank, that field. If you buy in a seed from Cotswolds or whoever else, then that seed isn't going to, it might do a really good job and it might do really, really well, but it might not be as genetically predisposed to perform as something that is kind of your soils. So that's that to answer the kind of second part of Sam's question about what's better, out of the bag or, you know, genetic diversity from within the farm, then within the farm is going to mean probably more resilience, better persistence in terms of plants. That's not to say that bought-in diversity isn't good, and actually over time, bringing plants, you know, those plants will adapt because of epigenetics, so they will be able to maintain diversity, and actually it will become more disposed to the setting that they're in. There is a comment from Janet saying importing plants from other places means you're importing disease, and it also means that ultimately everywhere looks the same and the local distinctiveness of a place is lost. I think that's a really important point. Yellow rattle chalk downland subspecies is better on the downs compared to yellow rattle from clay fields. So there are subspecies within these particular plant species, which obviously clever botanists can tell the difference. People like me just go, oh, it's yellow rattle. But there are kind of subspecies that are more suited to different places. I do think we run the risk of throwing herbal lays at everything and then losing some of the really rich, important, diverse native plants that we have. And I always find it really interesting to pull all the kind of herbal lay plants out and then go, right, let's go and look for their native counterparts. And actually we realize that we've got native counterparts on our farms. We just sometimes forget that they're there. So my very personal view is that that native species-rich pasture is far superior, for example, than GS4. As I said, a very personal view, and I also recognise the attractiveness of a payment rate that goes with those options. In terms of increasing diversity, I think maybe what we might have to do, because we have gone past Q2, is come back to that at another time. But there's a webinar that I chaired, 2 webinars that I chaired that were all about that. So I will see if I can find the links. They were hosted or paid for, managed by the Land Workers Alliance Future Farming program a couple of years ago, and the place where they were hosted doesn't seem accessible anymore. So I will see if I can chase down those 2 webinars, which basically looked at, I think Tom Chapman and Rob Havard both contributed to those, and I think Fidelity, did you do one of those as well, or was that your, or maybe yours? I'm thinking of your bale grazing one for Pasture for Life. Or you're on mute.
I did something a while ago with plant life. That was during COVID. I think you're talking about more recent things, aren't you?
No, it was like second round of COVID, though I kind of got confused by how many COVID rounds we got through. But
yes.
Yeah, I will see if I can find those webinars, because they go through basically the options of how you can increase diversity, which might be of interest to attendees.
Definitely. In fact, we did about 3 or 4 with plant life. That was in the very early days of COVID. And we had some really interesting speakers, including Rob Havard, giving 20 minutes on his bale grazing and the species he's reintroduced as a result of it.
Yeah, cool. Okay. So I think we'll stop there, because we're at 10 to 9 and everyone's probably quite tired. And I definitely am struggling to see now. Doing that much without my glasses has been tricky. So yeah, thank you so much for your contribution. So homework for next week. Sorry, I almost forgot. I would be really interested if you're able to do an infiltration test. That's a big ask. It would be great if you could. Actually, it's probably not ideal because it has been too wet. But if you're in an area that hasn't had quite as much rain, then you'd be welcome to go and do an infiltration test. I think that would be potentially very interesting. If not, what I would be really interested in you doing is having a look out for actually, if you could go in, actually this is much easier than infiltration, don't worry about that. If you could go into your field and take a photo looking down. So look, what I want you to do is stand in some pasture that, if you're grazing still, go and do it just as you're about to go into grazing, and take a photo looking down on, like bird's eye view of the ground below you, where your feet are. And I'd be really interested to see actually what some of you are going on to grazing at the moment, how green it is, whether there's a mixed bite, whether there's any soil present. It'd be really, really interesting just to see kind of the variety of what folk are grazing at the moment and what they're going on to. I will do the same, and I will share that as well. I'll put it in my presentation. So if you could, go into a field that you're about to graze, if you're grazing outside still, aerial sort of bird's eye view down onto the soil, down onto the sward, and let's all have a look and compare and see what we're all grazing at the moment. And if you could just send them either to Sarah or Deborah via WhatsApp or email, that would be fab. Okay, great. Great stuff. Right. Thanks ever so much for your time. Thank you, Sam. It was great to have you here. Thank you, Fidelity, as well, for your input. And Christine, thank you as well.
Thank you.
Thank you very much.
Thanks, folks. Take care.